Hello everyone, I am DHANASEKARAN, Triple E Department of TCE. In this video, I am going to share a presentation on capacitor. Let's see the presentation. My topic outline includes introduction, types, capacitance, and then properties of a capacitor and charging a capacitor, and then capacitor in parallel and series and their uses. Let's start with introduction. Now, what is capacitor? The capacitor is an device that store electric charges, and it consists of two plates which is separated by an insulator, that is dielectrics, which is non-conductive region can either be a vacuum or an electrical insulator known as dielectrics, glass, air, paper, semiconductors, so much. And then it variety of sizes and shapes, and the symbol of the capacitor is shown in screen. Now we are going to see the types of the capacitor. Normally there is a parallel plate capacitor and cylindrical capacitor in usage. What is the difference between parallel plate capacitance and cylindrical capacitor? So in parallel plate capacitor there is two plate which is separated by an dielectrics, and in cylindrical capacitor there is an circular plates and inside it there is an dielectric. This is the difference between these capacitor. Now in addition to that, there is an fixed and variable capacitor given in our textbook. The fixed capacitor are divided as polyester capacitor, ceramic capacitor, electrolytic capacitor, and then variable capacitor like dimmer, flame drum capacitors. Now what is capacitance, which is a very important thing in capacitor, and what are the factors that determine the capacitance? So the first point is surface area of the plates, which is majorly takes part in capacitance. The larger the area, the greater the capacitance. And second point is the spacing between the plates. The smaller the spacing, the greater the capacitance. And the last one, permittivity of the material. The higher the permittivity and the greater the capacitance. These are the factors that determine the capacitance. Now the capacitance is given by C equal to epsilon naught A by D, which is shown in screen. And then the basics of capacitor are ability to store charge, and unit of capacitance is farad. Capacitance values are normally smaller, such as mu f, nf or picof, and the capacitance formula equal to q divided by v. Capacitance of the capacitor is directly proportional to the charge on that capacitor and inversely proportional to the voltage in words. Okay, these are the basics of the capacitor. Let me introduce the properties of the capacitor. What is the properties of the capacitor? The capacitor that behaves as the properties given to it. What are the properties? Let me list out it. First one, when the voltage across a capacitor is not changing with time, the current through the capacitor is zero. That is DC voltage. This point shows a capacitor in an open circuit to DC. It shows a capacitor is an open circuit to DC. However, if a battery is connected across a capacitor, the capacitor charges. It defines the charging of capacitor in DC voltage. And then second point includes the voltage on the capacitor must be continuous. This shows the voltage and capacitor cannot change abruptly. And then the third point is the ideal capacitor does not dissipate energy. It shows The ideal capacitor will not waste any energy and it make use of every single part of energy. That is, it takes power from the circuit when storing energy and in its field and return previously stored energy when delivering power to the circuit. If we take a ideal capacitor, the storing energy and delivering energy will be same for ideal capacitor only. This is the point of 3. We see the fourth point as a real non-ideal capacitor has a parallel model leakage resistance. This will called as leakage resistance. These leakage resistance may be as high as 100 mega ohm and can be neglected for most practical applications. These are the important properties of capacitor, and we are going to see storing charge and capacitor. Let me know how many of you know how to charge a capacitor. All of you know, but here is the some points to make use of capacitor to charge. First of all, we have to connect to a voltage source and then positive charges starts flowing towards one plate of capacitors and negative towards other. These are all happens, and due to dielectric charges start accumulating on plate surface and the potential rises becomes zero. Flow of charge stops when the capacitor potential becomes equal to potential of the battery. That means same case with negative charges. So charge store on a capacitor in this way. So we have to connect to the voltage source. It is the main source for storing charge and capacitor. Okay, let me see a capacitor in parallel and capacitor in series. First of all, how to connect a capacitor in parallel, which is shown in diagram, and there is in this diagram there is an 3 capacitor which is connected in parallel connections. In this parallel connection there is an voltage source, that is V equal to VAB. Capacitor 1 carries Q1 charge, capacitor 2 carries Q2 charge, capacitor 3 carries Q3 charge. And how this circuit works, voltage remains same. In parallel capacitors, voltage remains same, and the equivalent capacitance of two capacitors connected in a parallel is the sum of the individual capacitance. This is the formula of the parallel capacitors. So we can calculate the total capacitance of the capacitor by this formula: C equivalent equal to C1 plus C2 plus C3 plus etc. How many capacitors are connected in parallel? Just sum of it we can calculate equivalent capacitance of the capacitor. Now we are going to see capacitor in series. So series means the capacitors are connected in series position with the voltage source. Voltage as same as V equal to VAB, and Q1 capacitor carries plus Q and minus Q charge as same as C2 and C3. Now there is a formula for finding V equivalent. In these series capacitors charge remains same, but in parallel the voltage remains same. So here charge remains same, and the equivalent capacitance of two capacitors connected in series is the sum of individual capacitance, which is reciprocal in nature. For n capacitor in series, we can use this formula to find capacitance equivalent, that is 1 by capacitance equivalent equal to 1 by C1 plus 1 by C2 plus 1 by C3 plus etc. How many capacitors are in use we can submit in the reciprocal. This is in nature. And then last one we are see the uses of capacitor in this world. So there is many uses in uses of capacitor and in this world, and I list out some of this. Capacitors for energy storage, capacitors for power conditioning, capacitor as sensor, capacitor for signal processing. So these are all the main uses of capacitors. These uses are very important one in this world, and here is my end. Thank you.